This is problem number 3 on the sample test problems for test number 2. Evaluate each of the following without using a calculator. Give exact answers. So for all or almost all of these questions, we're going to be using the unit circles, so make sure you have that handy. Pause the video here if you don't have it yet. So the first two questions are for the cosine of 3 pi over 4 and the sine of 3 pi over 4. So we're going to go to our unit circle, and we're going to find 3 pi over 4. So 3 pi over 4 is this angle right here. So what we're interested in is that angle. Remember, our angles always start from the positive x-axis and go counterclockwise. That's the default. So 3 pi over 4, and we've got these two numbers. And the only other fact that you need to answer this question is that when you're looking at an x and a y on our unit circle, that the x is the cosine of the angle, and the y is the sine of the angle. And so if I'm interested in the cosine of this particular angle, the cosine is the x. So the cosine in this case is negative root 2 over 2, and the sine value is the y, positive root 2 over 2. So those are my two answers for A and B. So cosine of 3 pi over 4 is negative root 2 over 2, and sine of 3 pi over 4 is positive 2 over 2. Parts C and D ask about a different angle, negative 2 pi over 3. So let's see if we can find negative 2 pi over 3. Okay, so I do see up in this picture positive 2 pi over 3, which is here. So positive 2 pi over 3 corresponds to that line and this angle, but we want negative 2 pi over 3, which means we need to go to the clockwise version of that same angle. So this line right here is the first one that I saw in the second quadrant. So I went all the way through the first quadrant, and then I got to the first line in the next quadrant. So the one that I want in going the clockwise direction must say go all the way through the first quadrant and then come to the first line that I see in the second quadrant. So I'll draw the 2 pi over 3 angle in purple, and then hopefully we see that the corresponding one is down here. It's that 4 pi over 3. And so this is the angle that we're interested in. That is negative 2 pi over 3, which is exactly the same, of course, as the 5 pi over 3, lands you on the same spot. And again, we just need to know the cosine is the x value and the sine is the y value. So just take a look at those numbers here. The cosine of negative 2 pi over 3 is this x, negative 1/2, and then the sine is the y, negative root 3 over 2. So cosine was negative 1/2, and sine was negative root 3 over 2. For part E, we're looking for cosine of 8 pi. Let's go back to our unit circle. So we know that if we make one complete trip around the circle, and that's an angle of 2 pi, and in this case we're going 8 pi, so that must be more than one trip. So let's see if we can figure out how many trips that is. All right, so the first revolution is 2 pi, next revolution is another 2 pi, so that's 4 pi total. Third revolution brings me to 6 pi, a fourth revolution gets me to exactly 8 pi. So 8 pi must be just landing me back on this point right here with the 1 and with the 0. So it says here that this is the 0 angle, which is true. It's also the 2 pi angle. It's also the 4 pi angle. It's also 6 pi and 8 pi. And I write that those things are equal. I mean, like, these things are not equal. Those are different numbers up there. But in terms of the angle that you land on, they all land you on the same point. And so the cosine of 8 pi must be the thing in yellow there, the x coordinate, which is 1, and the sine of 8 pi is 0. So the cosine of 8 pi is 1, and the sine of 8 pi is 0. Part G, the secant of 5 pi over 6. So let's find 5 pi over 6 in our picture. Let's see, 5 pi over 6 is this angle. Secant, let's see. So we need to know what the secant is in terms of either sine or cosine. And hopefully we know that secant is 1 over, and then you got to put the right thing down here. Secant is 1 over the cosine. And so what is the cosine of 5 pi over 6? Well, again, we've got an x and we've got a y. Now, which one is cosine? Cosine is always the x. So my answer is 1 divided by that thing in yellow. 1 divided by negative root 3 over 2. Okay, so this is equal to 1 divided by negative root 3 over 2. And all we need to do is clean this up just a tiny bit. The 1 divided by has the same effect as flipping over the number. So negative 2 over root 3. Some folks don't like having radicals in the bottom. I don't mind them. So this answer is good for me, but feel free to rationalize if you wish. Negative 2 root 3 over 3. It gets that radical out of the bottom. Next part, tangent of negative pi over 3. So if we look here, we're going to find pi over 3 is there. So pi over 3 must be this angle, but we want negative pi over 3. So that angle, I guess, is the last line I hit in the first quadrant. So then if I'm in here, I don't want the first second, I want the last line that I hit in that quadrant down there. So it must be that the angle that we're interested in, the one that corresponds to pi over 3, is actually this one over here, 5 pi over 3, which is the same as negative pi over 3 in terms of the angle that you land on. And again, all we need is the x is cosine and the y is the sine. So we'll highlight the x in yellow and the y in green. So the cosine of negative pi over 3 is 1/2, and the sine of negative pi over 3 is negative root 3 over 2. What we're looking for here is the tangent of negative pi over 3. So the extra piece of information that we need here, so we're down here at this is the angle we're focusing on right now. So what we need to know about tangent is that the tangent of an angle is the y-coordinate over the x-coordinate. You could also think of it as the sine over the cosine. So we take, for these points right here, the y, and we divide it by the x. So negative root 3 over 2 divided by 1/2. And it seems like we should clean that up a little bit too. So if you write it as negative root 3 over 2, division becomes multiplication, and then you flip the thing that's in the bottom. So the 1/2 becomes 2 over 1, and you see that the 2's cancel. So we just get root 3 over 1, or root 3 with a negative. So the tangent of this angle, negative pi over 3, is negative root 3. Okay, and then just a couple left down here. Part I, the inverse tangent of 1. So what that means is we're looking for an angle whose tangent is equal to 1. So translating this, I'm looking for an angle so that the tangent of that angle is 1. Okay, what does it mean to talk about the tangent of an angle? Well, we know the tangent of an angle is the y over the x. So I'm looking for some point on my unit circle where the y over the x is 1. Well, if you multiply by x, then you see that we need y and x to be exactly the same number. Okay, so let's see if we can find on the unit circle a point where the y and the x are exactly the same. All right, there are a few different candidates here. Looking for places where the y and the x coordinate are the same. Looks like right there, they're both root 2 over 2. Over here, well, they're almost both root 2 over 2, but one of them is negative. So I don't think that answer is going to work because the x and the y aren't exactly the same. Down here, we see more root 2 over 2's. Oh, they're both negative in that case. So again, the x is equal to the y. And then finally, there are some root 2 over 2's, but they're not exactly the same because one is negative and one is positive. So our two choices for the answer are that point right there, because that's where x and y are equal. And this point up here, because again, x and y are equal. So the only question is which one do we pick? Are we talking about the pi over 4, or is the answer 5 pi over 4? And if we allow two different answers, then we are making it so that the inverse tangent is not a function. And we need to pick one of those so that we have inverse tangent being a function. And it turns out that we have to think about the range of the inverse tangent function. And so here's our fact. If you have the inverse tangent of something, we define it to always live between pi over 2 and negative pi over 2. Said another way, we always make sure that the inverse tangent lives somewhere in either the fourth quadrant or the first quadrant. Negative pi over 2 is at the bottom, positive pi over 2 is at the top. So whenever you tell me inverse tangent and you ask me what it's equal to, I will always give you some number, some angle out there on the right-hand side of my unit circle, which means that this 5 pi over 4 down at the bottom is excluded, even though it's perfectly good. It gives you what you want. You wanted the tangent of some angle to equal 1, and it's true, the tangent of this angle equals 1. But we need to make tangent a function. And so everybody in the world agrees to pick an answer over in the first or fourth quadrant. And in this case, the answer, the only choice now is pi over 4. So inverse tangent of 1 is pi over 4. And I'll just highlight here, not 5 pi over 4, since inverse tangent of anything always has to be between minus pi over 2 and pi over 2. Finally, part J, we want the arc cosine of 3. Arc cosine means the same as inverse cosine. Translate that. If that looks more familiar to you, that's fine. So what we're looking for here is some angle so that the cosine of that angle is 3. Okay, so the cosine we know is always the x. So we're looking for a point on our unit circle where the x coordinate is 3. And we'll go to our unit circle and see if we can find a point where the x coordinate is 3. So looking at all the x's, let's see, here's an x that's 1. Here's an x that's root 3 over 2. There's another x, lots of x's. That's an x that's 0. Whoops. That's an x that's equal to 0. So it seems like the biggest x I'm going to find is at the far right. So that's the biggest x. And the smallest x, for what it's worth, is at the far left. And that makes sense because we know that cosine is always trapped between minus 1 and 1. So what does that mean about this question? Well, let's see. We know that cosine of any angle is always trapped between minus 1 and 1. The biggest cosine could ever be is positive 1. So can you find me an angle where the cosine of the angle is 3? The answer is no, can't. So we have a good laugh at the expense of this question. Our cosine of 3 is not defined.